Welcome back to Jackson Square. Here we are again, still looking at TEAC 6.3c, saying I can model integer operations with concrete models. So today we're going to be looking at how to use our counters and our number line for multiplying and or dividing integers with models. So the first thing we want to look at is just our reminder. So here today I'll be using open and closed circles. Our open circles will be positive. Our shaded circles or closed circles will be negative. Remember, open and a closed together will create a zero pair. Okay? So we have a problem here. It says 3 times 4 is red. How do we read this? So I hope that you remember when we're reading multiplication, it's read a certain way. So this is actually saying 3 groups of 4. Okay? So this is 3 groups of 4. So think about multiplication. Multiplication is repeated addition. We're making groups of a number to get our answer. So this is 3 groups of 4. So we want to take the same concept and start applying it to these next problems. And I'm going to model it. So the second one, the next one says 2 times 4, which is 2 groups of 4. 2 groups of 4. So I'm going to have group 1 and group 2. And each one of my groups, I'm going to have 4. And our numbers are positive, so my counters will be open. So if I have 2 groups of 4, how many do I have total? I have 8. The next one says 2 groups of negative 4. So 2 groups of negative 4, or we could say the opposite of 4, which is negative 4. So again, I'm going to have 2 groups, group 1, group 2. This time in my groups, I'm going to have negative, so I'm going to shade them in. In group 1, I will have 4 shaded. And in group 2, I will have 4 shaded. So now, how many do I have total? I have 8, but this time they're all shaded, so that's a negative 8. Okay, so take a second to look at problem 1 and problem 2 and see what the difference is. I have the same amount of groups, but what I had in my groups was different. One time I had a positive, and one time I had the opposite of 4, which was a negative 4. So our next problem says 2 groups of negative 5. 2 groups of negative 5. So again, 2 groups, 1 group, 2 group. This time in my groups, I'm going to have 5 counters. And they're negative, so I'm going to shade them so we know. So if I have 2 groups of negative 5, how many total counters do I have? Or what are my counters? I have negative 10 counters. So we've looked at these 3 problems. Oops, excuse me. We've looked at these 3 problems. Take a second to look at them, see how they're similar, see how they're different. And then there's a question posed here. It says, if 2 groups of 4 is 8 and 2 groups of negative 4 is negative 8, then what do you think the opposite of 2 groups of negative 4 equals? What is the opposite of 2 groups of negative 4 equal? Take a second and think about that. If 2 groups of 4 equals 8 and 2 groups of negative 4 is negative 8, then what is the opposite of 2 groups of negative 4? So hopefully you thought about that, and what you came up with is you can't have negative groups, right? There's no such thing as a negative group. I can't have a negative group. So that's why this is definitely read as the opposite of, right? Because you can't have negative two groups. So let's put a little reminder there. There cannot be negative groups. There cannot be negative groups, okay? So let's look at what, I'm going to write it how I wrote it. The opposite of two groups of -4, okay? So we know that two groups of -4 is a -8. So what's the opposite of a -8? The opposite of a -8 would be a +8, okay? So we cannot have negative groups. So if you see a negative sign in the front, we make sure that we read that as the opposite of, okay? So the opposite of two groups of -4 will give me a +8. So this is the opposite of, and then it's two groups of -4. 2 times a -4, we know based here is a -8. And the opposite of -8 is a +8. We can't have negative groups. So we kind of want to leave that negative to the outside, work what's on the inside, what's our grouping, and then find the opposite of that final answer. Okay? You can also look at these problems and see if you notice any patterns. We'll talk about this later when we get to division, but did you notice any patterns when you had two groups of 4 and two groups of -4? Two groups of -5, when I have the opposite of two groups of -4. How did our products look? How did our products look? What kind of pattern did you see? So today we're not only doing counters, we're also doing the number line. With multiplication and division, we don't spend as much time on the number line as we do with addition and subtraction, but we definitely want to look at it and see how it looks differently. So now we're going to try to model the following problems with a number line. And your model is going to begin at 0, just like with addition and subtraction. So that does not change. And we always want to make sure that we're writing out what we see. So our first one says 3 times 3, which is 3 groups of 3. Okay? And both of our numbers are positive. So when we model multiplication and division, it looks differently from addition and subtraction. In addition and subtraction, we use straight arrows that are going in these different directions. When we're talking about multiplication, because it's repeated addition, we are jumping in groups. So we're going to be jumping more than one number at a time. So here we have 3 groups of 3. So we're going to be jumping in groups of 3, and there should be 3 jumps. So we're going to start at 0, which is here, and I'm going to have 3 groups of 3. So from my first jump, I'm going to go from 0 to 3. That's my first jump. And I'm going to make these different colors so you can see. And then my second jump is another group of 3. So it'll go from 3 to 6. And then my last jump is going to be from 6 to 9. So this is 1 group, 2 groups, 3 groups. Those are my 3 groups of 3. I'm jumping by 3. So I start at 0 and then I'm going to my product. So 3 groups of 3 gives us 9. That was my final answer. Let me see if I can zoom this in a little bit closer. All right, so that's my 3 groups of 3. Let's try another. Here we have what? 5 groups of -1. So what's going to be in my group? I'm going to be jumping by -1. Okay, so since it's negative, I'm going to be going to the left. And how many jumps will I have? 5. I'm going to have 5 groups of -1. Where do I start? 0. We always start at 0. So I'm going to, again, try to color code these. So I'm going to start from 0 and go to -1. That's 1 jump. Then from -1 to -2, that's 2 jumps. Then from -2 to 3, 3 jumps. 4 jumps. 5 jumps. So my product is -5. Okay? So again, I'm going to show you my groups. I should have 5 groups of -1. So this one is smaller, so I'm just going to write the number 1 group, 2 groups, 3 groups, 4 groups, 5 groups. 5 groups of -1. I start at 0 and I go to my product. So I have 5 groups of -1. Let's look at 2 more. Take a second. What is this? I can't hear you. What is it? Yes. So hopefully you said it is 2 groups of -3. 2 groups of -3. So I'm going to have 2 jumps, and every time I jump, I'm going to be jumping -3. So again, we start at 0. We're going to start at 0, and I'm going to go from 0, and my first jump is going to land me on -3. And then my second jump is going to land me 3 more from that. And I will fall on the opposite of 6 or -6. So I have 2 groups. This is group uno, group dos, and I'm jumping by 3s. So just think about how this looks so much different compared to a addition or subtraction. Addition or subtraction, you normally have those straight arrows going here and then going there. Here we're jumping in groups, okay? What is this one? Yes, it is 2 groups of 5. 2 groups of 5. And both of these are positive, so I'm going in the positive direction. I'm going to start at 0, and then I'm going to make my first jump all the way to 5. Jump 1, group 1. And then my second jump is going to be another group of 5, which is going to land me on positive 10. Okay? So there are my 2 jumps. And I just want to zoom out so you can see all of these. And just look how different they look compared to, again, compared to addition and subtraction. You can see those jumps, those leaps, right? We have another question for thought. If 3 groups of 3 is 9, and 3 groups of -3 is -9, then what do you think the opposite of 3 groups of -3 will equal? What do you think the opposite of 3 groups of -3 will equal? Take some time to think about this. There'll be a discussion post. Post your answer. What do you think the opposite of 3 groups of -3 will equal? And why? And what did you learn the first time we had one of these? So I hope this helps. I hope you enjoyed multiplying with counters and how it looks on the number line. Good luck.